Before I talk in depth about how to graph an equation, a linear equation, so I talk very broad strokes, what these numbers mean. And you've heard this before, I'm sure, but I'm gonna go over it one more time. So this form of an equation, of a linear equation right here, y equals some number x plus some number, is in what we call slope-intercept form, where this number that's connected to the x here, this number times x is the slope, and this number at the end here plus something is the y-intercept. And how that applies to the graph, is the y-intercept is our starting point. It's where we're starting from. So if you think about any kind of business, any kind of medical field, whatever, knowing where you're starting from is kind of an important concept. We need to know where we're starting from, and then we need to know how fast we're going. And that's really what these two pieces of information tell us. So the starting point, I'm just going to make a random dot, is right there. Now the starting point is always on the y-axis. So remember, this is the y-axis, this is the x-axis right there. So the starting point is our y-intercept. It's where it crosses the y-axis, and that's where our line is going to start from. The slope is going to tell us how things are changing. So slope is all about change, and that's why it comes up in middle school all the way up through calculus. Slope is really, really important. Things are always changing. So I've got written here, you may have never seen it written in this way before, but the slope is asking us, how did the y change compared to how the x changed? So these triangles we call delta y, delta x. That's the change in y compared to the change in x. So in the graph, graphically what that means is y is going to change. It's going to go up and down some amount. I'm going to go up in this case. So I'm going to go up some amount of change. And then I'm going to go x change. So there's a change in x and there's a change in y. It didn't stay right where it was. It changed, it increased, and an x changed, it increased. So now I've got a new point. And then we keep going. Change in y, change in x, change in y, change in x. And we don't have to go in increments. This is called discrete math. This would be like in 1 month, 2 months, 3 months, what's going to happen? How is our business, our profits going up? Or whatever we're talking about. You could go in half months. You could go in quarter months. You get where I'm going with this. You really have an infinite number of time. You can break time as small as you want. Every second, how are our profits changing? And when we put those infinite number of points in there, we start to get a line. So that's where this line is coming from that we're getting. And we could go into negative time. That kind of falls apart with my example of a business here. And one of the purposes of this is if we want to make any kind of a prediction, we can say, okay, we've been in business for 3 years. I'm changing my time scale now to years. We've been in business for 3 years. What do we project is going to happen in 5 years? Well, we can't see into the future, but we can try and make a prediction based on the information that we have here. And that's kind of the big picture general idea. All right, so let's look at an example. I've got my graph paper here. So I'm going to graph, and we'll zoom out. There we go. I'm going to graph the equation y equals 2x, we'll go with minus 5. That'll be my equation that I'm graphing. Minus 5, that's the y-intercept. So that's the y-intercept. That's where it's going to cross the y-axis. That's my starting point. So I'm starting on the y-axis at negative 5. I'm going to use red here just so you can see it better. But that's my y-intercept, negative 5. And it's always on the y-axis for that number. The slope then is going to tell me how things are changing. So the slope, well, this isn't written as a fraction. Remember, I just said that the slope was the change in x, the change in y compared to the change in x. You can write any number as a fraction, any whole number as a fraction. 2 is the same as 2 divided by 1. So I've rewritten that slope as 2 divided by 1, which tells me that the change in y that delta y, the change in y, means that it goes up 2. And the reason I know it goes up 2 instead of down 2 is because this is a positive number. If this was a negative 2, I'd go down 2. But I'm going to go up 2. I have a rise of 2. And then the change in x, again, positive, is a positive 1. So I'm going to go up 2. And I'm going to go change in x of 1. And that slope will continue. That rate of change, how this business is changing, how this medicine is changing, how I don't know, whatever it is changing, keeps on going. And it goes in both directions. You know, I'm talking about a change in x or a change in y and a change of x as being positive. So I'm going positive here. It'd be kind of silly to write it this way, but you could. You could write 2 over 1 as negative 2 over negative 1. Remember, negative divided by a negative is positive. So it is really the same number, just written in a really funky way. And the only reason I would want to do this is because now I can start at my y-intercept, and I could go negative 2, down 2, negative 1, back 1. And you're going to see that that line continues. So the line does continue in both directions. You can take it both ways from that y-intercept, even if it is a positive slope. And here's the math behind why it works. You don't have to ever do that. You don't have to rewrite it. You just have to know that it can go up 2 over 1, up 2 over 1, or it can go down 2, back 1, down 2, back 1. That line will continue, and it should be a straight line if you can draw a straight line, which I apparently can't, when you're all done. So that's how you graph those equations, is you start with the y-intercept. You start at the beginning, at the starting point. It's always on the y-axis. And then you use this slope to tell us how things are changing. And that rise over run, you maybe heard, tells you your vertical change, your change in y, and your horizontal change, your change in x. And then you make a dot. And then you keep going, up 2 over 1, up 2 over 1. If it is a fraction, if the slope is like 3/5, then you would go rise of 3 and a run of 5. You'd go up 3 and over 5. Positive 3, up 3, over 5, positive 5 in the x. If it's not a fraction, if it's a whole number, you can always put it over 1, because you can always divide by 1 and make it into a fraction. I hope that helps. If you want another example, let me know.